Our goal is to try to solve this differential equation. You have e to power 2y minus y times cosine x dy dx equals to e to power y sine 2x, and you have initial value or initial condition here. It says whenever x is 0, your y becomes 0. So let us try solving this problem. What are we going to do? We're going to divide the equation by e to power y cosine x. We're going to have all dy's and y terms on one side and bring all x terms to the other side. It becomes e to power 2y minus y divided by e to power y dy equals to sine 2x divided by cosine x dx. So it should be very easy for you to see that when you divide by e to power y cosine x, cosine and cosine, they get disappear. That's how you end up with just e to power y on one side. And when you divide this by e to power y cosine y, e to power y get disappeared and you end up with sine 2x divided by cosine x dx. We just brought this dx to the other side. So now you have all y's on one side and all x's on the other side. This is indeed a separable differential equation. Let us take the integral of both sides. The integral of the quantity on the left-hand side, which is the integral of e to power 2y minus y divided by e to power y dy. And on the right-hand side, you're going to take the integral with respect to x, which is the integral of sine 2x divided by cosine x dx. Before taking the integral, our goal is to simplify these two so we can break it down into simpler steps. For e to power 2y minus y divided by e to power y, we can separate these into two fractions. It's going to be e to power 2y divided by e to power y minus y over e to power y, which in turn can be simplified into e to power y minus y e to power negative y. When you have e to power 2y, it means that you have e to power y times e to power y. One of e to power y get cancelled out, so you end up with e to power y minus y. And you bring this guy to the numerator, it gets negative exponent. So this is for the left-hand side. For the right-hand side, we're going to go back to pre-calculus. So the integral on the left-hand side is basically e to power y minus y e to power negative y dy. For the right-hand side, you have sine 2x, which we know from pre-calculus is equal to 2 sine x cosine x. Divide both sides by cosine x to simplify it further. As you can see, cosine x is the common factor. It gets cancelled out. So the integral on the right-hand side is now 2 times the integral of sine x dx. So before taking any integral, try to see if you can simplify it as much as you can. The integral on the left-hand side is now simplified to integral of e to power y minus y e to power negative y dy, and the integral on the right-hand side, which initially was in quotient form, is now a simple sine integral. So we just saw that we simplified the integral on the left and the integral on the right. To calculate the integral on the left, the integral of e to power y dy minus the integral of y e to power negative y dy. Calculating this integral is super easy because you have the integral of e to power y, which is e to power y. But for the integral on this side, here you have to apply the integration by parts method. And on the right-hand side, you have 2 times the integral of sine x dx. So as we mentioned, the integral on the left-hand side, the integral of e to power y dy is e to power y However, for the integral of y e to power negative y, you're going to use the method of integration by part. If you have the integral of u dv, it can be simplified as uv minus integral v du. With correct choice, you can easily simplify your integral. So the integral of y e to power negative y dy is basically following the same pattern. Take u to be y and dv to be e to power negative y dy. Take the derivative of this equation and take the integral of this equation. The derivative of u is du and the derivative of y is 1 dy. And v is the integral of e to power negative y dy, which is negative e to power negative y. So the integral of y e to power negative y dy, which is uv minus integral v du, can be written as y, which is your u, v, which is negative e to power negative y, minus the integral of negative e to power negative y dy. So let's go back to our integral itself. The first integral is the integral of e to power y dy, which is e to power y. And here you have the negative integral of y e to power negative y dy. If you distribute negative sign, here you get y e to power negative y plus e to power negative y. And on the right-hand side, you have 2 times the integral of sine x, which is basically negative 2 cosine x plus c. Very well. What about the initial condition? The initial condition was when x is equal to 0, y is equal to 0. So if you plug that in here, you get e to power 0, which is 1, plus 0 plus 1 over e to power 0, which is 1 again. So far you have 2 on left-hand side. And you have negative 2 cosine of 0, which is negative 2 plus c. So 2 plus 2 gives you 4. You could easily calculate c, which is 4. What's the use of it? It means that now we can just take this c and substitute it back here and write the particular solution this way. E to power y plus y e to power negative y plus e to power negative y is equal to 4 minus 2 cosine x. So we found a particular solution for this differential equation. And as you can see, we applied multiple methods going back to calculus. And again, here we're using the integration by parts method in calculating the integral of y e to power negative y.